Hi everyone. I hope you're having a lovely Sunday. It's quite late in the year to be doing a lesson, so I appreciate everybody who's sort of turned up and is ready to get started. Can everyone hear me okay? Hi Mathilde. We're probably going to wait maybe like a minute to see if anybody else turns up, and then we can get started properly. You've got mocks. Yeah, I think this is probably why lots of people are, even though it's the 22nd, turning up to this. Welcome. Good evening to you too, person man. I like your username. You got your mocks at the beginning of January. Yeah, I know that some people have done them already, but lots of people, it's the beginning of January. Hi, Fazzy. Nice to see you. I always say nice to see you, but I can't actually see you. It's very sort of like nice to see names. Okay. Maybe give it another 30 seconds. Does anyone have any nice plans for their time off, or is it going to be all revision all the time? Can't tell if my computer's lagging or if you guys just have absolutely no plans. So I'm going to get started. Okay. Can everybody see the screen okay? Hi. So yes, so the plan for this session, actually, I'll start by telling you guys what we're going to be looking at today. So the plan for this session is essentially to sort of go through a few exam questions. Like it's sort of like half of them are just for year 12, as in like they only have year 12 content. And then the year 13 stuff is stuff that you sort of already come across if you're in year 12, but maybe not in as much detail. And I'll sort of like help to explain as I go. And then there'll be stuff in there for the year 13s as well. So it's sort of like a bit of a spectrum, but we'll start sort of quite basic. So the exam boards that we made this for are OCR, Edexcel, and AQA. If you're on a different exam board, there might be stuff in here that's not useful, but it's still useful to know exam technique for everything. So I would stick around, and we plan for this to be like an hour long. So like we should be done by 8, and then I can go do Christmassy things, and so can you. Okay. So I'll introduce myself for anybody that's not met me before. I'm Georgia. I'm the chemistry human at SnapRevise, and hopefully I'll be able to help you with your exam technique before your mocks. So my degree was like kind of chemistry, mostly chemistry, but I did some neuroscience as well. And I've been teaching for about the last 6 years. So that should be useful for you guys. Your cat's watching. I love cats. I wish you could drop pictures in the chat because I would be really happy to see cats watching a chemistry video. As I said, AQA, OCR, Edexcel are the exam boards we're looking at. So I'm going to move forward. So the aim of this class today is we're going to sort of like be looking at how we look at questions. What's the important thing to read? I know lots of people have trouble with the idea that they actually do need to read the questions and not just skim it. We're going to be talking about the language that you need to be using in the answers so that you get the marks on the mark scheme. We're going to be thinking a little bit about exam technique, and it's just going to be sort of a range of questions. Cool. All right. And yes, Amy, I would suggest getting a subscription. And the thing that we're sort of pulling you in with is that somebody's going to get a free account. And the way you do that is that you take a screenshot of this web class, you follow us on Insta, and then you share it in your story, tagging us in. if you have got your Insta set to private, make sure you drop us a private message to say that you did this. Otherwise, we won't be able to see it. Cool. And then obviously everybody will get a coupon code so that the subscription is a little bit cheaper. Sherilyn, that is like super smart. If you want to enter, maybe download Insta and then delete it tomorrow after everything's been done and dusted. And I'm sorry to influence you to get your social media back. Cool. All right, so we're just gonna get started. So the first question is about boiling points and intermolecular forces. So hopefully all of you year 12 should have covered that already. So the boiling temperatures of fluorine are given below. So we've got fluorine as its diatomic molecule. So notice that I sort of start by reading the first line, and then I try and figure out how that's related to the stuff in the table. I know that sounds really obvious, but please don't just sort of glance down to the question itself. So first of all, we've got fluorine, which has a boiling point of 85. Then we've got methylfluorine or fluoromethane, which has a boiling point of 195. And then we have hydrogen fluoride, which has a boiling point of 293. So the molecule of diatomic fluorine, so F2, has 18 electrons, which intermolecular force depends to a large extent on the number of electrons in the molecule. Okay, so we're looking at a question about just this first part of the table. It's told us the number of electrons in it, and it's asked us about intermolecular forces. Cool, so what do we think? So Death Shadow, which is a very interesting name, is just getting a loading symbol. Is anybody else just getting a loading symbol, or is other people seem to be okay? Maybe refresh your page, Death Shadow. Yes, so lots of people are saying London forces, and that is exactly right. So what I will say is that London forces is sort of the best name you could use, because of course there's also has the name Van der Waals, but that name can sometimes be used as an umbrella term. So I wouldn't use that in your exam. Another sort of safe name is instantaneous induced dipole bond. That's also okay. But everybody seems happy with that, so I'm good to move on. So so we started off relatively simple. I hope that felt okay. And the next part is to calculate the number of electrons in our fluoromethane. So Toy World of Honey says, what's London forces? You may have heard of it as Van der Waals or as instantaneous induced dipole bonds. Do any of those ring a bell? Toy World of Honey? Hamna, it depends on who you're talking to, because before we used to use Van der Waals interactions as just a description of London forces / instantaneous induced dipole bonds. But now some people use them as an umbrella term for all intermolecular forces. So yes, for some people they are the same, and for others they are the same, but they include other things as well. So we kind of avoid putting them in exam answers for that reason. AQA doesn't mention London forces. Is it okay to use it? I'm pretty sure that it does. Adam, you might want to check some mark schemes specifically, but I'm pretty sure that AQA also accepts London forces. Why can you not say covalent bonds? Because they're not covalent bonds. So remember the difference between intermolecular, which means between separate molecules, and intramolecular, which means within a molecule. So because this is asking for intermolecular forces, we can't use something that joins a molecule together, like covalent bonds or ionic bonds, if that makes sense. So again, Van der Waals interactions is kind of like an umbrella term to some people. So we tend not to use Van der Waals as the term in exams. We use London forces or instantaneous induced dipole bonds. But yes, it is Van der Waals. It's just that terminology is a bit dodgy at the moment. Yes, we will be covering year 13 content just a little bit further in, just so everybody's comfortable. So I'm going to move on to the next question because I'm getting a little bit distracted by all of your lovely comments. It's actually really nice. Cool. So Right, so calculate the number of electrons in the molecule of carbon, hydrogen, and fluorine. So we've got fluoromethane. So of course we want to look at how many are in carbon, how many are in hydrogen, and how many are in fluorine. So I'm getting lots of different answers. So how many electrons are in carbon, first of all? Yes, everything is for AQ8, Edexcel, OCR. I will. So 12 in carbon. So remember, we're looking at electrons. 12 is the relative atomic mass, which is protons plus neutrons. So there's not 12. How many are there? 6, yeah. So there's 6 in carbon, right? If you're thinking of the number of electrons, that's the same as your proton number. And there's 6 in carbon. How many are there in, what's the proton number for hydrogen, or the number of electrons? Yeah, lots of people getting 6. Yeah, thank you, Karima. Thank you, Mona. Yeah, there's 1. But there's 3 hydrogens, right? So how many in total? Yeah, 3. Thank you, Fatima. Oh, Fatima, it's nice to see. And then fluorine. So if you guys don't have a periodic table open, you should get one open. 9, yeah, fluorine's atomic number. So proton number is the same as the number of electrons. So yes, cool. So if you guys add them up, I'm getting lots of people saying 18, which is correct. So yes, if you don't have a periodic table on paper, there's a website called P-Table, like literally like this, that has a really awesome periodic table. I'm a little bit obsessed with it because I'm a big nerd. Okay, cool, let's move on. All right, so the next one is again sort of intermolecular forces. So the question asks why the boiling point of fluoromethane is greater than that of F2, so diatomic fluorine, referring to the intermolecular bonds present. So the first thing we're going to think about is the fact that it's 1 mark, right? So you always want to check how many marks are, which means that we really don't need to go into much detail at all. We're just going to be thinking about like 1 sentence kind of thing. So what we're going to do is sort of pop back to the question. So we're going to just make sure that the information is correct. So we know that fluorine has a boiling point of 85, that fluoromethane is 195. So we have that in mind. So so we don't want to be thinking about covalent bonds, FASI, because we're thinking about intermolecular forces, which means the forces between the molecules rather than intramolecular forces, which is the forces that hold together the molecule. And covalent bonds hold together molecules, so you don't want to think about that. And then I've got lots of answers saying hydrogen bonds. And hydrogen bonds is a dodgy answer. So what I'm going to do is draw out my fluoromethane. What do we require for hydrogen bonding? Somebody drop me a comment. As in, like, what does a molecule need to contain? What kind of bonds does it need to contain inside the molecule? Yeah, so we're getting lots of different answers. What does it need to contain that this doesn't have, that fluoromethane doesn't have? Yeah, thank you, Hannah. Yeah, fluorine actually needs to be bonded to the hydrogen. So I'm assuming you guys have remembered that hydrogen bonding happens between molecules with hydrogen and either fluorine, oxygen, or nitrogen, but it actually has to be bonded. So for example, this will, and that is probably going to come up in the next question. So yes, so we don't have hydrogen bonding because the fluorine's not actually bonded to the hydrogen. So what is the type of intermolecular force between our fluoromethane? What's the strongest one? Yeah, thank you, Zahara. So yes, so it's our permanent dipole bonds are present. And we don't even need to talk about the fact that fluorine only has London forces because it's already been in part A. So it's not asking us to talk about that. It's just literally asking us to say permanent dipole bonds. So Khadija says, what is a dipole bond? And really quickly, I'm gonna, if you guys remember your concept of electronegativity, it's the ability of an atom or an element to pull electrons in a covalent bond towards itself. So fluorine is the most electronegative atom there is, which means it has a partial negative charge. So when it's bonded to the carbon, that has a partial positive charge, which means that the fluorine part of fluoromethane is going to have electrostatic attraction towards the carbons in the other fluoromethanes around it. And that's what we mean by a permanent dipole bond. And I saw some, van der Waals is not a good answer for this question. This question, you have to be talking about a permanent dipole bond. Van der Waals is not specific and often refers to an instantaneous induced dipole bond, which is not the same thing. Is this because of its position on the periodic table? Yes, there is a trend in the periodic table that runs from the top right at fluorine, which is the most electronegative, and down to the bottom left at like cesium and francium, which are the least electronegative. How do I know that fluorine is electronegative? I remember my trend on the periodic table. I look and the top right has fluorine, and that's the most electronegative, and it goes on a diagonal down to the bottom left, which is the least electronegative. So if you remember that trend and you look at your periodic table in your exam, you'll know what's the most electronegative. Cool, I'm gonna move on. I do not answer everybody's questions. I keep missing them. There's too many people saying things, I can't keep up, but I try my best. Yes, Jonathan, fluorine has a Pauling value of 4. The Pauling scale measures electronegativity between 0 and 4, and fluorine has the highest. Okay, next question. Explain why the boiling temperature of hydrogen fluoride is the highest in the series. So this is sort of our last. So if we think about HF, yeah, hydrogen bonds, because we actually do have a bond between the hydrogen and the fluorine, which means that we have a very strong hydrogen bond between any nearby hydrogen fluoride. And notice this question, obviously it doesn't ask you to draw it, but notice that I've got the hydrogen bonds at 180 degrees, which you need. Notice that I've got a lone pair of electrons forming the hydrogen bond, and I've got my partial charges. Those are really important. Yeah, so Ujiha says hydrogen bonding, so stronger bonds, so more energy needs to break the bonds, which is correct. So it's 2 marks, so I'm going to say 2 things. So we've all identified that there's hydrogen bonding. Hydrogen bonds are also present, and that takes more energy to break, and that's all you need to say. Wajiha, if it had said, or Wajia, let me know if I'm pronouncing your name wrong. If it was 3 marks, I might mention that they're stronger, but it's 2 marks. So we only really need to say 2 things. Do you get the electronegativity values in your, probably not on the actual periodic table? I would say break. Yeah, Amy. So like, this is really an exam technique thing. What you want to do is look at your marks, the number of marks for each question. If it's 2 marks, say 2 things. If it's 1 mark, say 1 thing, and so on. Like, obviously, if you have time at the end and you want to add more details just to be sure that you've hit everything, then do that. But if you're the kind of person that's really tight on time, I would really try and stick to the number of marks. You don't need to know exact values. You only need to know the trend. If you need to know the exact values, you will be given them. Do we have to? No, you don't. Unless it asks you specifically about the Pauling scale, usually it's perfectly enough to say that something is more electronegative than something else. Yeah, exactly, Giraffe Okapi. I love that name. They might have them and they might give you a certain table. You need to know what the Pauling scale is, that it runs between 0 and 4, that 4 is the most electronegative and 0 is the least electronegative. Nothing's actually 0. You can't have anything with a proton in it that can't pull electrons, but it runs between those 2. Your teacher told you about Birmingham forces, Adam. I've never heard of Birmingham forces, but maybe they're a thing. Yes, I'm going to continue. Yes, FT. Cool. So the next thing we're going to talk about is getting a little bit higher level. We're going to be talking about organic chemistry. So the question is about 6 alcohols. So we've been given the proper names for 6 alcohols: butan 2-ol, 2-methyl-pentan-3-ol, propan 1-ol, ethane 1,2-diol, 2-methyl-propan 2-ol, and propan 2-ol. So we've got a bunch of alcohols that we're going to be talking about. Thank you, Cheryl, for like dropping that in there for me, and Amy. Cheers. Okay, so the first question says, which alcohol is an example of a tertiary alcohol? So the first question I'm going to ask you guys is, what is a tertiary alcohol? So I'm getting lots of answers saying 2-methyl-propan-2-ol. So that is correct. Somebody tell me what a tertiary alcohol is anyway, and then I'm going to sort of drop that in. Kira, if you're bad at naming compounds, then you should definitely stay. That's okay, Amy. I'm going to walk you through, I'm going to sort of try and keep this as open to everybody as possible. So I'm going to walk through why. And so even if you're not sure, you'll still be learning. Yeah, so Adam Andrew says the OH is attached to 3 carbons, which is kind of correct. It's attached to a carbon with 3 carbons. So with our alcohols, you can either have a primary alcohol. Primary has a carbon chain, and at the end of the carbon chain, there is an OH group. A secondary alcohol will have a carbon that's joined to 2 other carbons, and so on. And a tertiary alcohol will have a carbon that's joined to 3 other carbons with an OH group. So what we're trying to think about is which of those is true. And lots of people correctly said 2-methyl-propanol. So no, 2-methyl-propan-2-ol. And we know that that is correct because 2-methyl-propan-2-ol, which we will draw in a second to explain, so I won't bother to draw it now. So we've got 2-methyl-propan-2-ol, and it's asked for the skeletal formula. So I'm going to just draw that for you, because otherwise I don't see how I can ask you guys to draw that for me in the answer. So I'm going to draw it for you. So we've got 2-methyl. So this is going to be my carbon 1. This is going to be my carbon 2. So it's 2-methyl. So then I'm going to shove in my methyl group straight away there. Then I need a carbon 3. So it's asked, oh, actually, okay. So this is a good teaching moment. Notice that I was like, oh, it's going to ask me to draw it down here. And so I can just show you guys the question. Yeah, thank you, Danya. I can just show it you in the question. So this is a perfect example of how tricky organic chemistry can be in an exam. If you make the assumption that it's the same as the one above, like I just did, you will lose your marks. So it's asking you for 2-methyl-pentan-3-ol, which I will keep drawing and then go back to the last one. So I've got 1, 2, I put my methyl group on the second carbon. On number 3, it says it's a 3-ol, so I'm going to put my OH on the third. And pentan is how many carbons? Yeah, 5. So I need 1, 2, 3, 4, 5. So that should be fine. So I'm going to go back and draw my 2-methyl-propan-2-ol just so you guys have a good idea of what it looks like. So it's a propan, which means that there's 3 carbons, and it also has 2 methyl groups on the second carbon as with the OH group. So there it is there. Okay, so the next part of the question is butan. So Im says, I have a question. How did you know that the tertiary alcohol directly without drawing each alcohol? Is there a mental way you can apply it? Yes, there is. So notice that 2-methyl-propan-2-ol, yes, 2-methyl-propan-2-ol has 2 separate types of group on the second carbon, right? So it's got, if we know that they're all on the second carbon, and I shouldn't have that many. If we know that they're on the second carbon, then we know that we've got multiple groups on the second carbon, which means that it's going to be tertiary. So check the groups. Cool. So butan 2-ol and 2-methyl-propan-2-ol are structural isomers. what is meant by the term structural isomers. So this is something you need to memorize. There's just a good definition. So yeah, it says structural isomers are molecules that have the same molecular formula but a different structural formula, which is perfect. So if you don't remember that definition, try to memorize it now. It comes up with fair regularity, so there's a good chance you'll need to know it. And it's just a simple, easy extra mark. So please shove that in your mind, brains. Different structural formula. Ah, Amy, I'm so jealous. I wish I was eating a nice cookie. Although I did eat sort of quite a few gingerbread biscuits today because it's almost Christmas, and what is Christmas without gingerbread? Okay, cool. All right. So it's asking us, it says, draw another structural isomer of these two alcohols. So what I'm going to do is go back. So we know that it's butan 2-ol. So I'm going to write that down so we just have it on the screen. So butan 2-ol. And we also want 2-methyl propan 2-ol. So 2-methyl propan 2-ol. So we want another structural isomer for these two alcohols. So somebody give me some, yes, I do have an excuse, Amy. Christmas has no calories in my mind. Okay, so there's like one sort of quite simple structural isomer that's quite simple to name also. So if we're thinking about different structural isomers for butan 2-ol, what might be another structural isomer for butan 2-ol? Yeah, so I'm getting a few good ones as well. So Adam, butan 3-ol doesn't exist. What do we call, oh no, butan, sorry, I'm thinking propan. Yeah, we could do 3-ol or 1-ol. So 1, 2, 3, 4. So whenever I do skeletal formulas, and this is good for everybody to do, after I've drawn it, I always recount my carbons because it's so easy to just add an extra one. So please do the same. And I've got some other, yeah, I've got some other suggestions. So actually do tell me, why does butan 3-ol not work? What's butan 3-ol the same as? And why? Yeah, thanks, Maya. So butan 3-ol is the same as butan 2-ol. If I draw it, 1, 2, 3, 4, I could number the carbons this way so that I would have butan 2-ol, or I could number the carbons from this direction and make it butan 3-ol. So butan, yes, it's symmetry. So you could flip the molecule. So you can't use butan 3-ol, but I did have some other suggestions in there. I had 1,2-dimethyl ethanol. Natasha, is that how you pronounce that? Natasha? Have a think about why methyl groups on an ethanol is not technically different. Have a think. And I'm going to come back to that in a second. I had some other options as well. I had 2-methyl propan 1-ol. So 2-methyl propan 1-ol, let's try that one. So we've got a propan, so 1, 2, 3, 2-methyl, so 2 groups in there, and then, so sorry, and 1, does that one work? How do we feel about that? Yes? Yeah, that one works. So Toy World of Honey says, why does it have to be shown in the skeletal formula and not the structural formula? And it doesn't. It doesn't need to be shown that way. But I find that the structural sort of representation that students find most difficult is skeletal. So I use skeletal to get you guys used to skeletal. It's also a lot quicker. So once you get the hang of it, it's a lot easier to use. So I would practice the one you find hardest. The one you find easiest is not going to be your problem, right? Cool. So the next part of the question says ethane 1,2-diol can be dissolved in water to act as an antifreeze in car radiators. Explain why ethane 1,2-diol is very soluble in water. Yaz says ethane 1,2-diol is very soluble because it contains two OH groups which can form hydrogen bonds. Specifically, the compound can form two hydrogen bonds. Yes, hydrogen bonds with what though? What makes something, so it says soluble in water. What's it forming hydrogen bonds with? Yeah, so if you just said it can form hydrogen bonds, that would have been 1 mark. And we know that it's 2. And if we want to follow the logical reasoning, we need to say that it forms them with water. So it contains hydroxyl OH groups which form hydrogen bonds with water. And it was a good shout to say that it forms 2 hydrogen bonds. If it was 3 marks, I'd be more tempted to shove that in, but it's 2 marks. So I'm going to assume it's 1 that forms hydrogen bonds with its hydroxyl groups and 1 about water. Hydrogen bonds do form because they are polar, but they also form because it's hydrogen bonds with lone pairs. So you don't just want to say polar molecules, you want to say hydrogen bonding. Yeah, I mean, like, Adam, if you're the kind of person that always has time at the end, or like often has time at the end, then go ahead and write more stuff in. Of course, you want to hit as many marks as possible. But if you're the kind of person that's often really rushed off their feet by the end, then I would suggest trying to limit yourself. Ghosted Guna. I love all of these display names. We don't specifically make it for that exam board. It's probably, organic chemistry is kind of universal. So there's definitely going to be useful things in here, but it's not going to be exactly the same mark scheme wise. So, I mean, like, stick around, but don't assume that this is exactly what your mark scheme says. Adam says that it's Birmingham forces. Is your teacher from Birmingham? You can say OH. I put both just in case somebody was confused about hydroxyl. Your teacher's not from Birmingham? Is your school in Birmingham? She's from London? I have no idea. Ask your teacher. Okay. All right. So the next part of the question is quite year 13-y, just because you guys, your year 12s may not have come across this, but it's also just a memorizing thing. So don't worry, year 12s, there's not going to be any concepts in this that you can't possibly understand. So ethane 1,2-diol is heated under reflux with ethanoic acid and a small amount of sulfuric acid catalyst. Compound A is formed with the molecular formula C6H10O4. Draw the structure of compound A. So, people, what kinds of things form when things are reacted with an acid catalyst? Yeah, so I'm getting, yeah. So I'm getting lots of good answers. So I'm getting carboxylic acids and I'm getting esters. So you might get a carboxylic acid forming, right? But if we have this long formula here, so you will get a carboxylic acid forming and reacting, but we've got a C6H10O4. So what's likely to have happened to 2 of the carboxylic acids? So we've got ethanoic acid reacting with ethane 1,2-diol. They come together and make esters, yeah. So we want to make sure we've got ethane 1,2-diol and ethanoic acid coming together as an ester. So I'm going to start by drawing my ethane 1,2-diol, and I'm going to draw it in the middle, and I'm going to go again in skeletal formula to give you guys practice. So my ethane 1,2-diol, so remember this is this 1 carbon here, 1 carbon here, and 2 oxygens here. So we also have an ethanoic acid, and I'm going to sort of keep the molecules as they are for now, and then I'm going to show the reaction product. So we've got ethanoic acid. So that should be an OH group and a carboxyl group, and that's 1, 2 carbons. And I also can have an ethanoic acid over here, right? And the reason I've drawn 3 of them is because we've got a C6, which means that we must have 6 carbons, which means there must be 3 molecules involved. So that's 1, 2, 3, 4, 5, 6 carbons. And now I need to sort of do the condensation reaction between my my diol and my hydroxyl groups. So what comes out of condensation reactions, people? Yeah, so I hope that makes more sense, Javier. That it called, yeah, okay, you said you got it now. Yeah, water's going to come out. So we're going to lose 2 hydrogens and an oxygen on each side, which makes sense, right? So I'm going to get rid of this this hydrogen. I'm going to get rid of that OH. I'm going to shove these together because it makes more sense if they're together. So that's one side, and I'm just going to do the same on the other side. Merry Christmas to you too, Aman. Cool. Yes, condensation reactions are really, really common in biological molecules. That's how a lot of polymerization takes place in the body, in any other organism. So it's useful to know both. So Javier says, so it's diethyl ethanoate. So it's, you have to name the fact that it's got 2 ester groups. You can't just name one of the ester groups. Okay, so the next part of the question is butantuol is heated with sulfuric acid. A mixture of 3 alkenes forms B, C, and D. The alkenes B and C are stereoisomers. Draw the structures of the 2 stereoisomers B and C. So tell me, guys, what kind of isomerism are we thinking about? Yeah, we're going to be thinking about EZ isomerism, or some of you may have seen it as cis-trans. More of an outdated name, but EZ, cis-trans, whatever. Yep, Harry says carbon-carbon double bond, no free rotation. Yes, perfect. Okay, so we've got butantuol heated with, we've got alkenes formed. So if we've got alkenes formed of butantuol, how many carbons are they going to have? So Amy, this is this part of the question is still year 13 stuff. EZ isomerism, you will see in a second what that means. That's interesting, Miss Trippy, because Caitlyn Jenner is trans, not cis, but sure. So like you can call some things both EZ and cis-trans, and then some things can only be described with EZ isomerism. We used to use just the cis-trans system, and then we realized that it didn't apply particularly well when you have multiple functional groups. So we moved on to an EZ notation. So this part of the question is year 13, but stick around because we're going to be chopping and changing in between. Cool. So how many carbons do we think we're going to have in these alkenes if it comes from butantuol? 4, yeah, thank you, Fazzy. I wouldn't say this is the hardest side. I would say that this EZ isomerism is not too bad. So I'm going to draw it both in skeletal form and in structural form because it asks for the structures, so I'm going to do both. So if we have the 2 forms, this one is going to be what? Is it going to be E or Z? Or cis or trans? Yeah, it's definitely because you haven't done it yet, Amy. I wouldn't worry too much. Yeah, so this one is cis or yeah. Is it? So lots of people are saying E. Be careful. So remember, the way I like to remember it is that the Z isomer is the one that doesn't look like a Z. It's really annoying that the Z isomer is not the Z looking one. That would be very useful, but it's not. So because this one on the left does not look like a Z, it's the Z isomer. And because this one on the right does look like a Z, it's the E isomer. So I'm going to also draw this out. So Amy, if you're having a look at this, all EZ isomerism is about is whether two groups of an alkene are on the same side or on a different side. That's all it is. It's not too bad of a topic once you get there. Cool. Yeah, I don't know why. I mean, like, I do know why they're opposite because they're German words, but it's very annoying. Cool. Moving on. So we've kind of already answered the question. So which one is E and which one is Z again? Z is the one that doesn't look like a Z. E is the one that does look like a Z. Rather confusing me. Thank you, Hedge, and Gagan and Zusammen. I probably butchered that. Sorry for anybody who is a native German speaker. So trans is E. So this one is both trans. So trans just means different from before. So like they're on different sides, trans, and it's also the E isomer. This is the cis isomer and the Z isomer. So what I would say is don't use cis trans in your exam unless it asks you specifically which one it is, because it's kind of an outdated terminology, but you do find lots of chemists still use it. So it's useful to sort of know. Thank you, Giraffe Okapi. I'm so glad that my German is not awful. Awesome. So we've already said what kind of stereoisomerism is shown by B and C. We know that it's EZ isomerism. We've been talking about it this whole time. So I'm just going to write it in. All right. So the next part of the question is draw the structure of the other alkene D that is formed in this reaction. So we've been given, we have two stereoisomers of this butane. So we know it's a butane, there's 4 carbons, there's nothing else in there. So we've got 2 butanes, both of which has a double bond in the middle, right? So what's the other isomer that's going to form? Yeah, thank you, Maya. So but 1-ene is the last one that we haven't formed yet. Which can also be drawn like this. Awesome. Okay, so the next parts of the questions sort of like, we're not going to have, sadly not going to have time to sort of go through all of it, I don't think. But the next part of the questions are about our analytical methods. So we've mass spec thing in here, which all of our year 12 should have come across before, most likely, unless your teachers have done things like a weird way round. Lots of people, this should be year 12 and 13. Mass spec tends to come up in both. So you should have covered it in year 12 unless your teachers have sort of left it to right at the end. So this is year 12 friendly. And we also have an infrared spectrum, which is you tend to only do in year 13, but don't worry, it won't be confusing because it just refers to a table. So we're going to read the question. Alcohol E is one of the following alcohols. So this is the alcohol list that we got at the beginning. We've got butyol, 2-methyl-pentan-3-ol, and so on. I'm not going to read them again. Dania, you're just going to have to get Instagram. Just get Instagram and delete it after. So a student oxidizes alcohol E by heating under reflux with an excess of acidified potassium dichromate, and organic product F is isolated. So my year 13, please tell me what is formed when you heat something with acidified potassium dichromate. Yeah, so carboxylic acid or what? Yeah, thank you. When under reflux. What's the other option? Can't be an aldehyde if it's under reflux. If it's under reflux, it will go to completion, but there's another option. Yeah, thank you, Javier. So it could also be a ketone if we have a secondary alcohol. So year 12s, don't worry about that. Just keep in mind, we're looking for a carboxylic acid. We know that we're working towards a carboxylic acid or a ketone. So that's all you need to think about. Adam, I'm in London. There's definitely Insta. I'm in London. I grew up in London. We have Insta. Okay, so Ibby, that's not really a polite thing to say. Please avoid stereotypes like that. Okay, so mass spectrum of alcohol E is shown below. So I want us to first think about what's the most useful part of this mass spec? What's the thing that's going to sort of like give us the most information about what we have in our products? So this is, remember this is, it says the mass spectrum of the alcohol E. So this is our starting product, not our end product. Yeah, so I'm getting lots of people saying the molecular ion peak. And if you can't, ooh, I zoomed in. Never done that before. Okay. What has happened? Does it still zoom? It does not still zoom. Okay. Cool. All right, so the most important peak that we're going to be looking at in a mass spectrum is the molecular ion peak, which is the entire molecule just sort of like with an electron bashed off, right? So that means this is our M+ peak, which means that we know our molecular mass is what? So I've already got some people saying it. So it's not 45. So the largest peak is not the tallest peak, it's the peak with the largest mass to charge ratio. So it's the peak furthest to the right-hand side. So don't mistake that for intensity. Yeah, so the molecular ion peak, so we have a molecular mass for this of 60. I've seen that so many times. It's a mistake very often made. The y-axis, so going up and down, is the intensity. So it's like how much of that thing there is. Whereas from left to right, the x-axis is your mass to charge ratio. So those are your masses. That's the important bit. So 60. So Race Ali Hassan, is your name Race? The M+1 peak is not on all of the exam boards, so I have not included one with an M+1 peak. You can also tell there isn't one, just for people whose exam board it is on, because we don't have two peaks together right at the end. We just have an M+ peak. If there were two, if there was one at 60 and 61, there would be an M+1 peak. Yes, oof be doof. Oof be doof. Great, another great name. Yes, so the y-axis up and down, that's abundance. Your name is Race. Cool. How do we calculate the peak? Hi, House. You don't need to calculate the peaks. Even when you go and do a chemistry degree, you like give the lab techs your sample and they very kindly go and run the mass spec for you. So it's a machine that does this. You don't have to calculate the peak. Nobody has, the machine calculates the peak. Okay, we're going to move forwards because I'm only going to be talking about this for another 2 minutes. So all I'm going to do is do very briefly, it says the infrared spectrum of our organic product, F, is shown below. So this is our product, not our reactant. So we've got this infrared spectrum. And we know we're looking for either a carboxylic acid or a ketone. So year 12, if you haven't looked, if you haven't come across this yet, it's not that complicated because essentially you're looking at the wave numbers and you're given a table of the bonds that show that infrared peak. So you really don't need to know anything apart from you have a table here and we're trying to identify what some of the largest peaks are. So I've got Adam saying no alcohol present, which is not necessarily true, right? So if I'm going to have a look at this peak here, this sort of very small peak, and it's broad. So we also want to keep an eye on whether it's narrow or broad. And we've got a broad peak, and it's a little one, but it's there at 3,000. And if we have a look here, we can see that carboxylic acids, their OH, if you just Google infrared spectrum table, it'll come up. But you should have one in your data booklet. So we have an OH from a carboxylic acid. So there's no alcohol present, but there is a hydroxyl present. So I'm going to name this an OH in a carboxylic acid, which tells us that we don't have a ketone, we have a carboxylic acid. Not an alcohol though. Yeah, you're right. But it is an OH. So I just wanted to sort of, yeah. And we know that it's a carboxylic acid because it's a broad peak. Okay, so let's identify some of our other peaks. So we've got this massive peak here that's like roughly, so remember that the numbers go down. So this is about 2,200 and something, not sorry, I just did the thing I meant for you not to do. It's about 1,700 because the numbers go down. So what's around 1,700? What could it be? Yes, it will be available in your exam. You aren't forced to remember these horrible values until you do chemistry degree. Yeah, it could be 1,700 is around here. So it's a C double O, it's a carboxyl group. And we already know that it's from a carboxylic acid, right? Because we've identified the OH peak. So we know that this peak refers to a C double O. And I'm gonna just look at maybe this peak here, and then we're going to sort of finish off. So that's about 1,200. And what might that be? What's a logical thing? Yeah, that's all that infrared requires you to do, IM. Yeah, so the most logical thing to think is a CO. Or of course, we could say 1,200 could also be a fluoroalkane, but the important thing for infrared, and the reason that you have all of this information, so we have a starting product, starting reactant, we have mass spec and infrared, is because context is so important. So this is probably a CO. So Fatima, the infrared is basically, you put a sample in an infrared spectrometer, and what you're looking at here is the frequencies or the wavelengths of infrared being absorbed by specific bonds. So it causes bond vibration when you absorb infrared radiation. So this is sort of that transmittance. What that means is at the wave number 1,700, most of that wave number is being absorbed. So most of that wave number of infrared is being absorbed by the C double O bond. But yes, so we're going to actually finish this sort of exam-y bit here. So well done, guys. We got through quite a bit. I'm surprised. I didn't think we were going to get this far. So we don't get to find out what it is. But right now, because the whole point of this is to introduce you guys to SnapRevise. So that's what I'm gonna talk about now. So I almost showed you the thing, but I didn't. So what I'm going to do is actually just show you the website. Because you guys have been so good. Now you get to see the cool SnapRevise website. I'm sure that's what everybody wants. What is SnapRevise? SnapRevise is this thing that I'm about to show you. It's a super cool website where you learn super useful A-level things. Okay, so the reason that we're doing this is because we launched this new version of us. Compliment me on my brain, not my face. My brain is the important thing. Cool. So I'm going to just walk you through sign up. So SnapRevise is essentially a website that allows you to, I'm going to be Georgia Hat. What should my password be, guys? Brummy Forces. I'm going to take that as my password. Thank you, Adam. And I'm going to be in the School of Life. Oh, look, it's already on there. Goodness. Oh, or just SCOO. Fine, that's fine. And I'm going to be in year 12. And of course, I want discounts because obviously. Awesome. All right. So you want to do more in your chemistry. Let's say you're AQA. You go ahead and you set a target. So let's say, obviously, I want an A star and I want to improve my grades because I'm not doing so well. Okay. So the whole point of SnapRevise is that we've got sort of three things that main things that we offer. We've got the course. So it's got everything from AQA, videos, very nicely explaining things. And the first thing that you do is a diagnostics quiz. So you go on and then you sort of answer questions. And then if you get them right, we sort of mark it as you sort of know everything, but if you get them wrong, like saying fluorine has 10 electrons, we know that you need to sort of study that bit. So it takes you to a really cool video that explains things really nicely. And then once you've done the video, you can go ahead and look at an exam question walkthrough, which is also really great. Yes, you can use somebody else's Insta, Dania, as long as that person agrees, then it's fine. Then you can do sort of exam question walkthroughs where we sort of run through an exam question. And then once you've done all of that and you feel really comfortable with the topic, you can go onto our exam pack, and basically we've got like a fudge ton of questions that we've come up with that should be sort of very well fitted for your mark schemes, for your specific exam board. Because you know when you like run out of exam questions, I'll get onto that in a sec, I am. And then you can sort of look at the model answer and mark it yourself. And then keep going, and we've sort of gamified it. So we tell you sort of how much you've gotten through based on what grade you wanted. So we also have a cool thing where you get me, which is obviously really great. So there's web classes, and they're a lot like this. So we might actually do, oh, look, it's me again. I find it embarrassing to see videos of myself. So we have web classes about each of our topics. So the next one for year 12 is about group 2, so our earth alkaline metals. And then the next one for year 13 should be electrochemical cells. And then you can ask me questions and we work through like the knowledge of the topic, and then we do exam questions. And then there's also drop-in sessions. Don't be so embarrassed, I'm fine. Oh, why, thank you, Harvard. Look at you guys supporting me to be less embarrassed and seeing videos of myself. It's all very strange though, seeing yourself on video. It's weird. Anyway, so the drop-in sessions, basically you can come in and ask me anything. I can help you with your homework. We can just go through random exam questions on a topic you're finding hard. So they happen twice a week as well. So essentially, we've just basically tried to come up with something that has everything that we think you might need to do well in your A-levels. And yes, how much it costs is a good question. So if you go for the basic, which is the videos and the exam question walkthrough, and you get like really pretty revision guides, then it's £10 a month or £9.99 a month. If you want the exam packs as well, so that's all of the like hundreds of exam questions, thousands, possibly thousands of exam questions, that's £30 a month. I really want an answer to your question. Sorry, Amy, I wasn't seeing the question. Once you sign up, can you do, say, chemistry, biology, and psychology from Samrovise? Yes, you can. We don't have as much psychology happening at the moment. So it's mainly chemistry and biology. The psych stuff is really, really teeny tiny. You can only get a basic package for that. But chemistry and biology is sort of like full thing pop up. Yes, the drop-in tutor does cost more. So the drop-in tutor is the ultimate package, which is the £50 a month one. So I know it sounds expensive. It is reasonably expensive, but compared to getting like a private tutor, it's cheap. Like a private tutor is like £30 an hour minimum, or like up to £50 an hour. So if you did that twice a week, it would rack up a lot. So we're essentially trying to make it cheaper for the people who would get a tutor, but they can't afford to get a tutor. So that's why it's that price. I know it sounds a lot, but you essentially can ask me questions anytime. Oh, I forgot to say, if you have the ultimate package, on any of the videos ever, you can ask me a question and I will reply within like a day. So you just like have an expert with you all the time, which is why it's expensive. So yes, so now that you guys have been fabulous and listened to me like pitch our fabulousness, I will give you the code for the discount. So here is your code. We provide a bursary? Not as of yet, Yaz. So the options are, for the people that really can't afford it, is lots of students have asked their schools to pay for it for all of the students doing specific A-levels. So that's an option. You can go to your head of department and ask them to do that. So go ahead and do that. If they can't afford it, then you can also suggest to them they do a split with you. Like the department pays some, like half of it for the students, and the students pay the other half. So that's, I've also seen schools do that. So if you can't afford it, do go to your school and sort of like be like, please, this resource is useful. We are also looking into, in the future, perhaps having some kind of bursary, but that's not confirmed. I would really love that to happen. Dania, your head of department, said no. I'm really sorry. But maybe, so somebody is going to win the Insta prize, right? So if you've all done that on Insta, so remember you're screenshotting this web class and then tagging us in your Insta story. Yaz, you should check, right? Because lots of the colleges and schools that are broke get like extra chunks of funding from the government to try and sort of like make up the difference between like socioeconomic divides. So they might actually have a budget to do something like this. So do check. How can we check your store? I don't know what that means, Adam. Why do you keep saying we don't have Instagram in London? Are you like the Snap Provides YouTube troll? Is that what's happening? When is the winner chosen? Soon. The winner will be announced on Instagram by tomorrow, really. So you should be able to see that. Why am I lying? I don't know. I don't know why I would think that Instagram could possibly exist in London, one of the biggest cities in the world. Yes, that would be very strange, wouldn't it? Okay, so you don't need codes for Insta. So the Insta thing is just screenshot the web class and then tag us in it. So we're Snap Provides. And then make sure if your Insta's on private that you like message us and tell us that you did that. Otherwise we aren't going to be able to see it. Could you have a follow back? I don't control the Instagram, but Amy, I will ask the person that controls the Insta. If I controlled the Insta, I would follow you back, Amy. What happens if you don't read our messages in time? Well, we are going to read all of our messages, so do it now and then you'll be fine. Yeah. It doesn't matter. As long as we can see, then it's fine. Are we doing any more exam questions? No, we're done. We're done for the day. We should have more of these YouTube things coming up as well. So you couldn't put a hashtag. That's okay. You just need to tag us in it. So @SnapProvides. All right. I'm done. I'm going to go eat cookies. No, I'm not. I already ate too many cookies. I will eat more cookies tomorrow. I'm glad you enjoyed it, Amy. I'm happy. No, don't go. Oh no, but what about Christmassy things? I have not wrapped my presents. I haven't even finished Christmas shopping yet. When will I do that? What's the best way to revise chemistry? I would say it really, Khadija, it depends why you feel like you're failing. It depends if you're actually failing or if it just feels like you're failing. It depends if you're not motivated. It depends if you're revising sort of inefficiently. So I always recommend doing like loads of exam questions and making sure that you like actually read the mark scheme and mark yourself really harshly, and then go back and redo the ones you didn't hit all the marks for. How long should you be revising for? Eat more cookies. Amy, you know what? I have to take your advice. You seem like a really smart person, so I'm going to have to eat more cookies. How long should you be revising for, Sadiqa? That's a really difficult question. I would say that you should come up with a timetable, know how many hours a day sort of like you need to be doing things like going to college or like life things like eating and sleeping, and then set aside like a percentage of that time to revise that still allows you to be human. So you still need to take breaks. You still need to like see your friends once in a while and talk to your family and things like that. But sort of like set aside time to do that, and the rest of the time, revise. Can we hang out sometime and have a study session? You know what? There's going to be a live study session at some point, like in person. So keep your eyes peeled for that. Your only friend is me? Oh no, you should really like get out there. Someone order you a pizza, Kira. Someone order me a pizza. If anyone's getting pizza, I should get maybe we can both have pizza. Anyway, I'm gonna stop talking about cookies and pizza, and I'm gonna go. Have a lovely Christmas, guys. Or if you're not celebrating Christmas, have a lovely day to just like chill. And everybody have a lovely New Year's. You're welcome. See you after Christmas, hopefully.